Hi guys, welcome to the DevFus Foam tutorial part 3 for the BAE Hawk. If you missed 1 and 2, I'll put a link to the playlist. So in this video we're going to start off with a little tip that may help here to get the formers better aligned to the drawing. Then we're going to do the wing slot with an MH42 aerofoil, and after that the canopy slot. And then the last part will generate G-code for one of the formers. I'm just going to do one of them because it would take quite a long time to show the whole process for all of them. So in the next video, part 4, I'll make all the files available, the project files and the G-code. So even if you haven't got a license for DevFus Foam 2, you should be able to run the G-code through your Hot Wire CNC machine. And if you haven't got a Hot Wire CNC machine, check on the website, there's details of how to build one. So let's start off with a tip. So if we're going to look at former number 8 as an example. And then go to edit full screen down at the bottom there. If we look at the 3D view, and if we take the sheeting off and take the side view off, what we can do, we can spin it around and see how the formers fit in relation to our drawing. So it's normally best to use one of these XY top and bottom views. So you can do a bottom which is not so good, but the top one's the best. And then what you can do is you can see how that relates to your drawing. So you can see we look to be a little bit on the large side there on the outside. So what we can do, so I think that's former number 9. So let's just check. Yeah. So what we can do, we can click the formers on and off. So that's former number 9. So if we go, former number 8 looks okay. Possibly former number 10 looks a little bit wide as well. So if we exit that and click A, then we'll click on 9. If we just double click there, we should go into editing. And what we can do, we can alter the width by these orange selectors here. These are called the slant angle. So I think we said it was a little bit large, yeah. So if we just, what we can do, we can, so we want the slant angle slightly bigger than that. Try that 17. So side off, sheeting off, XY top. Yeah, that's not looking too bad now. So that's how you can go and manipulate the former shape. So if we now put the sheeting back on, just spin round. So it looks like we're a little bit big on the back one as well. See the way it's going out like that. So let's kind of look at that one. Yeah, that looks better. So that's not looking too bad now. So what we'll do now is we'll move on to the next section, which is the wing slot. So this section is new to DevFus Foam 2. And what we can do here is add a wing slot. Now on the original version, there was no option to do this. So on my Hawker Hurricane, I had to make a template up and place it on the side of the fuselage and just use the hot wire on a bow to cut the airfoil section out, which was a little bit tricky, but it worked out okay. So we'll go in to add a new wing slot. And we've got a few different options here. The main thing we're going to need first of all is the root cord for the wing we're going to use and where it's going to be positioned. So you can see at the moment we've just got a rectangle and it's nowhere near where the wing should be. So what we need to do is jump back into our drawing with DraftSight and get these measurements. So when we've got the measurements, we'll come back. Right, so what we need to do now is we need to get the distance from the nose to the start of the root cord of the aerofoil and the distance of the root cord. But to do that we need to add some lines. And as you can see at the moment, it's not particularly easy to see. So what we'll do is we'll make the image transparent so we can still see it, but we can see these lines a lot easier. So the easiest way to do that is go to layers We'll create a new layer. We'll call it image. And then what we'll do, there's a transparency option there. Now if we change that to 30%, which seems to work quite well, and we say OK. Now at the moment nothing's happened because the image is still on layer 0. So what we can do is we've got the image layer selected, as you can see the bounding box around it. And if we just go up to layers in the properties palette there and select image, and the green shows up quite well. Right, so what we need to do now is put some construction lines in. So what we're going to do is put a line along here on the trailing edge, and we're going to need 2 lines here because there's a little bit of an angle in the root section of the wing, and another line here. So we'll just make sure entity snaps is off. So that's back on. So click again, so that goes off. And we don't want ortho on, so ortho's off now. So if we just select line, and the line command there, and then what we're going to do is just try and eyeball this. So we don't really need that section there because we're only really after this section in here. So we'll just do the section there and then draw the line out. And get it lined up as accurately as we can. Right, so that's enough for there. So we need to extend that line up to the centre line of the fuselage to give us our first measurement. So what we do is go to modify command, and we've got an extend option there, or we've got it across here on the tool palette. So we select extend, and the first thing it wants to know is where we want to extend it to, which is called the boundary edge. So we'll select the line there, and then we just select enter to say we finish selecting, then specify the segment, and now we click on the segment there and you should see it shoot up to the top. There we go. So that's extended there. So that will give us our measurement from there to there, but we still need the root measurement. So we'll draw another line, and we could probably snap to the edge of that there. So let's turn snaps back on, and then we'll draw another line. It's got the end point there. Now we want snaps off again. And this one. There's something about there. So that's our second line. So now we need to do the same thing again as extend that. So we'll select extend, specify bounding edge, that one again, enter, and then we select the line. So now we've got our chord length. So all we need to do now is some measurements. So we'll put snaps back on, because that's helpful now, because we can snap to these endpoints. And then we'll go to tools, inquiry, get distance. So it wants a start point, so we'll do the root chord first. So we snap to there, we snap to there. So that gives us 212 for our root. And now if we do up arrow, we can run the same command again, get distance, specify a start point, so we can go from there and then up to the nose section, and that's 268. So we've got 222 and 268, So we use their measurements on putting in the wing slot. So back in DevFus Foam 2, we'll now put their measurements in to add in a new wing slot. So we go to add a new wing slot. We'll give it a bit of a more meaningful name. Hawk wing, and then we'll put the measurements in that we got, which was 212, 268, and I worked out my testing that -8 gives us the right height of the slot. So if we apply that, so that's looking about the right distance now. What we need to do now is turn it into an aerofoil. So if we click on that file, and we can load a DAT file, and you can get these DAT files from quite a few different places, and I'll put some links in the video where you can get them from. So I've decided to use the MH42. So select that, and we can see now that looks pretty good now. So I'll just do an apply, and that's the wing slot done. So now we'll add the tail slot. So we just go add a new wing slot. We'll call it tail. And the way to get the position of the tail, there's two ways we can do it. We can either use draft site, as we did before, to get the measurements, or one way you can do it is just by using the actual drawing here. And if you look in the corner up here, we've got actually where the cursor is, so we can get the measurements that way. So we zoom in a little bit, so we can probably about the middle of that there. So that's showing 645.52. So if we put them as the dimensions there, 645.52, apply, and if we zoom, so that looks to be about the right position, but you see that slot's miles too long. And through my testing I worked out about 95mm works out about right. So if we apply that, I've decided not to use an aerofoil shape on the tail for ease of building really. So all I'm going to use here is some flat balsa and just have that sliding from the back, and then I'll shape some trailing and leading edges to give it a symmetrical shape. It's going to make the build a bit easier. I know the hawk, the tail does droop down a little bit at the end, but for ease of building I'm just going to keep it straight. So when you look from the back it will just look straight. So we can alter the size of that thickness here if we want to. So say we wanted 6mm, didn't apply, so that's a little bit smaller. So I might actually leave it at that. If I want to use a slightly thicker one, I can just ease it out a little bit and have a tight fit rather than having something that's a bit too sloppy. So if we say OK to that, and then we can do a 3D preview and see what we look like. It does take a little while to generate this. So there we are, we've got our 2 wing slots. So when we've cut out all the formers, what we're going to have to do then is put these formers back into the CNC machine at right angles to the wire, and then it will cut these sections out. So I'm probably going to turn it upside down, and we can actually get the wire to come in from the back here, so we don't have to cut through the top of these. So the wire will actually come through the back there. So we'll show that on when we generate the G code. So that's the wing slot and the tail slot done. So we'll move on to the canopy now. Right, so when we go to add a canopy slot, we just put our new canopy slot. And it puts a default canopy in to start with, sort of based on some of the dimensions. But you can see obviously it's in the wrong place. So use the same method as we did for the tail slot. And basically what we're trying to line up is these 2 points here where you can see where there's a small blue X there. So that's what it's using for these dimensions here. So the front lower corner and the rear lower corner. So what I'll do is if we go to probably about the middle of there, I think. So that's, call it 112, shall we, by 41. So if we do 112 by 41, apply that. So that, yeah, let's go a little bit lower on that. 42. Zoom in there. Oh, wrong way. 40. Yeah, that looks about right. And then we can alter this angle here to make that more in line. But let's get the rear corner roughly the right position. So we want that round about here somewhere. Somewhere around about here. So that's 325, 84. 325, 84. Apply. Then you could do 2 slots here, but I think what I'm going to do to keep the build fairly simple, I think I'm just going to use one. I might bring this down a little bit lower, just to bring this down a little bit. So let's go 38. Bring that down a bit as well. Yeah, that's not looking too bad now. So we just need to alter the angles of these. So this is the angle on here, and it's a radius at the moment, which is this distance here, but we can alter that if we want to. So let's do the back one. I'll never get this right, so I have to try one way then the other. Let's try minus 20. Oh, that looks about right, that. Yeah, and what we can do, we can make this radius a bit less if we want. Let's halve that, let's go to 8. Yeah, that looks a bit better there. And then down here, we need to bring this up a little bit. So let's try 50. Gone the wrong way. Try 30. That's not bad. Let's try 29. Yeah, 31. Yeah, it's not bad. We'll alter this radius a little bit. We'll make it quite a curve. Let's try 6 on that. Yeah, so that's looking quite good, that. So if we apply that, say OK, and if we do a 3D preview, there we go. That took quite some time, that did. So if we just spin it around, there's our canopy slot. That's not getting too bad. As I said, if we wanted to, we could do this in 2 steps to make it follow the outline a bit more. So we're now ready to go into the G-code generation. So now we've finished with the design of our hawk, we can go into the G-code generation. So we'll be working on this side in DevFus Foam 2. And the first one we're going to do is the fuselage. Then after that we'll do the wing slot, and then after that we'll do the canopy slot. We won't be using 3-axis CNC milling, but what is quite useful is this one here, create report the selected project. And it just opens up in a browser and it shows us the sizes of the blocks. So this will help us in actually pre-cutting our blocks ready to go into the CNC machine. So the length here is actually the what I call the width of the foam. So I'm going to be using XPS foam, which is 60mm. So the front two ones are I'm going to have to cut in half to get me 30mm, and I've got 3 60mm there, 3 60mm there, and I've got this large one at the back which I'm going to have to make up. And I've got a very small one in the middle there at 12mm, and it'll give us the size of the blocks we need here as well. So that's quite useful, and I normally print that off and have it with me. So we'll go back into the cut fuselage blocks by CNC 4-axis. So what I try to do is pick a few of the same size, and so I can cut 2 or 3 at the same time. So what we'll do is we'll start off with the first two, block 1, and we just press shift to select 2 blocks, and then run wizard to create the CNC cut file for selected blocks. And what I do is I have the blocks inverted, so the wire comes in from what would be the bottom of the aeroplane. That's a little bit easier to hide and doesn't spoil the look so much. We've got here a space in between the blocks. I think it's got 10.01mm, which I think because it's been running in inches, it's just done a conversion. So I think I'm going to actually give that a little bit more. So I'm going to put 15mm in there. Update the preview. There we are, a little bit further apart. And it looks like there's a big gap there, but if we show the right side, so that's the bigger side. We show both sides. So this reference line height is this line here in red. So if we go onto there, we should see that's as near as I can get onto it, 47. So what you can do, you can alter these a bit if you want. So you can have it aligned, upper aligned. Now, because it's gone down, it's because the block's upside down. That's why it's moved to the, or you can use lower aligned. So that's aligning the bottom up there. We can do centered. That makes them like that. But I think what we're going to do is do these reference line align, because when we go in to do the canopy slots, we need these to be on the same plane, if you like. So that reference line, and when we put the blocks in, that's going to give us the same on each one. Become clearer as we go into it. So I never use this split blocks vertically, and we've got no joints in there, so we can leave that one. So go on to the next section. The next section is the kerf value. So this is how much foam is actually melted away as the wire passes through. And to be honest, I found these settings for the wire I use, which is very thin nichrome wire, works quite well. Yeah, but we can adjust them later if we need to. I normally run a couple of test parts first, just to make sure everything's going okay before I commit to doing the whole fuselage. So go on to next. Now this section here, we're looking at a top-down view of our CNC machine, and the red lines here are the distance the wire's going to take looking down from the top. What will happen here if we do test pass limits? Well, that one's okay, but normally my machine is set up at, when I'm doing wings, is set up at 810. So once you've changed the setting there, you need to go optimize X and Y placement. Now, if we do a test path limits now, we get an error. And the reason for that is, so we look at a side view and we show the actual carriage paths. You can see what's happened there. It's come out of the bounds of the machine, and the block would have to be this high in the machine. Because the machine is this wide, the wires on the side have to travel a hell of a distance to get that small little angle on them parts. So what I normally do is try and have this distance between the carriages as small as possible. So what I'm going to do on here is set it to 200. So that means I've got to adjust my machine for that. So we set it to 200. And you see what's happened now. It's moved it right down the bottom there, and it's telling us where the foam block needs to be placed. So the X and Y placement of the foam block. So it's saying the distance between there at the bottom there and there is 29 millimeters. So if we look at the side now and we show the actual path now, you can see why we've got that distance there. We could probably go in a bit smaller as well. So let's try 150. And we do optimize placement. Yeah. So you can see this wide distance is coming down. And I don't think we get much smaller than that 150 millimeters, not particularly. So what I try and do is keep this distance to the minimum, but we'll need to do a little bit of testing just to make sure that we've got enough distance there, because we've got a spring that's tensioned. We need to make sure that the spring's not going to interfere with the foam block at all. So we'll set that, and if we do test path limits now, we've got OK. And if we look at a 3D simulation, you can see now, zoom out a bit, take these side bits off. So this is what will come out of that. Go next. This section here I never use. This was pre-cut in your blocks. And then what we do now is I just go to create 4-axis G-code for both carriages. And we can put a description here. So I generally put the block, could spell block 1 and 2. And then I'll put width 30 millimeters, distance 150 millimeters, and then we generate a G code, and all the rest of the settings are fine. What you might need to do is change the carriages here if you've got a different setup. So I'm using U and V, my right axis, and I switch my wire on manually, so this setting here doesn't matter, but you could change that if you wanted to. So let's we do OK, and then we get the option to save. So it does remember where you saved your last section. I already saved the tail section. So what we'll do now, we'll put block 1 and 2. Save, and if we're going to have a look at that, So here we have the G code. So it's got our header we put in, and it also puts in some parameters itself. So we've actually got tower distance there as well, which is quite helpful. And we've got the offset from the left, the offset from the right. So that's where we place the actual foam block. And it's given us the material size and the offset. So the machine travel is, it's got 600mm on the x-axis and 300mm on the y-axis. So this will be the U and V as well. And here's all our G code. Not very exciting. And it still has the commands in to switch the wire on and off, but we're not using them. And then we get an end there. So we'll take that to the machine and see what happens. So what I'll do is I'll go through and generate all the others. It's basically the same process, and then we'll get all them blocks cut, and then we'll come back and do the wing slot. So that's the end of part 3. If you've made it this far through the video, thanks very much for watching. Really appreciate it if you'd like and subscribe. Part 4 should be out within the next 7 to 10 days. And if there's anything you're not sure about with DevFus Foam 2, just let me know in the comments and I'll do my best to give you an explanation. So catch you later, guys.